Hello guys, we are back with our next lecture. In this lecture, let us go through the differences between divide and conquer and dynamic programming. Okay, so basically divide and conquer we have learnt multiple algorithms already, right? Like merge sort, quick sort, binary search, and there are multiple algorithms which we have already learnt. But dynamic programming we didn't learn any algorithms, but we have some kind of introduction, right? In the last lecture only we have introduced about dynamic programming and we discussed what is the application or core application of this divide and conquer, dynamic programming. Okay, so in this lecture let us see the differences between divide and conquer and dynamic programming. Okay, so basically divide and conquer, I hope everyone remembers now at least divide and conquer. So here you will be taking a problem, dividing it into two parts. You'll be solving the left part, again you'll be dividing into two parts, you'll be solving the left part, and continuously you'll be dividing and solving them. And here remember that each problem is independent to each other, so there is no dependency between each problem, like it will not depend on the previous results. So those kind of problems will be coming under divide and conquer. Okay, sorry for that. So solving the problem by dividing into independent smaller sub problems is nothing but divide and conquer. Whereas dynamic programming is where you will be having some dependency. Like in our example, we taught about Fibonacci, right? So in Fibonacci of a 99 we are solving, we got 97 and 98. If you check inside 98, we are having again 97. So this is repeated here. So if you assume these two are separate sub problems, but it is independent, it is not independent, right? So this is dependent on this. So that is the reason why here we are having overlapping sub problems or dependency sub problems. Okay, so after that in divide and conquer, the sub problems are not dependent on each other, that is nothing but independent. Yeah, that's what I have just told you. In dynamic programming, the sub problems are dependent on each other, so there is some relation between both of the sub problems. Okay, so in divide and conquer we don't store any kind of solutions in between, like do not store the solution of sub problems, hence no need of any extra storage. Whereas in dynamic programming, we store solutions of sub problems, hence need of extra memory to the storage is needed, storage for data is needed. So if you notice here, I told you that we will be storing this 97 value somewhere, we'll be storing this 96 value somewhere. So if somewhere means it is somewhere in the memory, right? So that is the reason why you need some storage to store those intermediate values or the sub problem values. Okay, so divide and conquer applies a top down approach. So if you remember, you'll be having a big problem, you'll be dividing it into two parts. Again you'll be dividing it into two parts until it is a unit part or some kind of reference part. Then you'll be combining them. So this is nothing but top down approach. So that is the reason why divide and conquer is called as top down approach. Whereas dynamic programming, you might divide it into multiple parts, but you will be solving from bottom to top, right? So these two you will solve, this you will get, this two you will solve, you will be getting this, like this, like that. So bottom to top. So that is the reason why dynamic approach is called as bottom up approach. So the examples for divide and conquer are nothing but merge sort, quick sort, binary sort. So these are all the things which we have discussed already. And in dynamic programming, we are having matrix chain multiplication, all pair shortest path, which we will discuss in our further lectures. Okay, so I hope everyone got some clear idea on divide and conquer and dynamic programming. So in the next lecture, let us compare the differences between greedy and dynamic programming. So let us meet in the next tutorial. Thank you. Thanks for watching.